Hello there and welcome to a brand new video. This is Happy Beyond Numbers where we learn maths the easy way. Now in this video we are looking at vectors. We'll talk about the introduction to vectors and then do some one or two representation here and there. So without much I say, let's quickly go into it. When we talk of vectors, what comes into mind? So a vector quantity is simply a quantity that has both magnitude and direction. So looking at what we have on the screen here, it says a vector quantity is a quantity, or is that quantity which has both magnitude and direction. The important thing we have to take note of here is what? Magnitude. So you should have a magnitude and then you should have a direction. What this means is you should be able to measure it and you should be able to point out the direction or the path it is going to. You see, on the other hand, a scalar quantity is a quantity which has magnitude only. It has no direction. Here too, the most important word is it has magnitude only, but then have no direction. If we look at some examples, I think it would come clear to us. So when we talk of magnitude, the first typical example is force. The force being applied to a body. Why would we say force is a vector quantity? You can measure its magnitude. So for instance, you're applying 5 Newton to a body. Now, in what direction are you pushing or pulling? You see, that is why I would say a force is a vector quantity, because you can measure its magnitude and also tell in what direction it is being applied to. Same applies to velocity and then momentum as well over here. Then the scalar quantity, that which has magnitude only. So some examples we can look at is the time, the space, and the temperature. Then let's come to how we can represent vectors. When it comes to representation of vectors, there are two main ways. The first one we'll be looking at is the column representation. So there is the column form, which is also known as the component form, and we have the magnitude bearing form, or also known as the directional form, right? So we'll be looking at these two and then how to convert from one to the other. That is the main thing we'll be doing in this video. So let's quickly take a look at the column form or the component form. So talking of the column form, I would first start with what? The notation of vectors. So if I write vector A, B, with this line on it here, this line is very important. That also what shows that it's a vector. You see, so this here is telling that we have a vector that moves from A to B in this direction, A to B. So with this, we are saying that the column representation of vector AB is going to be X, Y. It's just like the coordinate, you see. So the X will simply refer to what? Its movement along the x-axis. That is from the east to the west. And then, or the horizontal movement. Whilst the Y will be our vertical movement. That is up and then down, or from the north to the south. You see, this is the column representation of vectors. It can also be written as this: A, B, being what? X, Y. You see, so you can write it as this form. And based on the notation of vectors, we can also see it sometimes being written as, so let's say if this vector is vector v, then it should be what? The same thing over here, X, Y. So what we have here are just notations of vectors we would come to in our next videos. So with this said, let's look at how we can represent the column vectors on our Cartesian plane or on our X, Y plane. So starting with this question here, it says we should represent vector YZ, which has the column component. You see, the column coordinate, or better still, it has been represented in the component form as 5, 2. We have to represent it graphically or on the Cartesian plane. So we need our Cartesian plane first of all. So this here is my Cartesian plane, if you can see that. You see? And on my Cartesian plane, I have my x-axis and I also have my y-axis. So the first point or the first component is with respect to the x-axis. So we come here and then locate our 5. And then it says we should move upwards, 2 steps upwards. So at this point 5, we should move 1, 2. So this is the point our vector is going to end. And if you take a look, it says from y to z. From y to z. So your origin here is where you are going to put your y. That is in this middle here. Then you draw your line. So if this is your y, it simply means this is your z. So we draw our line from y to z, you see, and we indicate the direction. So I'm going to use an arrow rather to do that, you see, very, very nicely, indicating the direction. So my y is here, and I have my z over here. That is just it. This here is our graphical representation of the vector y, z. You see, so let me do one more so we understand. So as you can see, the question here says we are to represent the vector BC, which has coordinates -3, -4 on the Cartesian plane. All it means is let us draw this on our graph sheet. So I would once again put my Cartesian plane here, and if you have your graph sheet, you can quickly draw your Cartesian plane. Now my points are -3 and -4. So I come to the x-axis. I'm going to put my x-axis here and my y-axis here. So on my x-axis, I look for the point -3. So this here is my -3. You see, we are moving. Negative means we should move towards the left. So this here is my -3. And then I'm going to look for 4 downwards. 4 downwards on the y-axis. So -3, I move 1, 2, 3, 4. Now this is my point. Then what do? I draw an arrow head. So something like this, you see. And it says from B to C. B to C, that is where the arrow should be pointing towards. So this origin here becomes my B, and then I have my C over here. Very, very simple. So here are some questions you can try on your own. It says you have to express the following vectors graphically. AB, that is 3, 4, PQ, 5, 7, MN, 0, 6, and then UV being 8, 0. I would like to end this video here. Then in the next one, we look at the magnitude bearing form. And if that doesn't take too much time, we'll also look at how to convert between these two forms. If this is your first time on this channel, this is Hub Beyond Numbers, where we learn maths the easy way. If you'd like to receive notifications and then update on any video I upload, then kindly subscribe. And you can also share or leave any comment in the comment section. Thank you very much for watching to the end, and I do hope that it helped. If there's anything you want me to know, once again, you can let me know at the comment section, or hit me up on Telegram or on my email on the scroll that is being shown on your screen. Stay blessed and then take care. Bye.